Hello students, today I am going to explain you chemical bonding, right? Chemical bonding is of three types generally. The first one is ionic, this is also called electrovalent, ionic, this is also called electrovalent. The second one is covalent, and the third one is coordinate covalent, right? So today I will explain you about the ionic bond. You will be surprised and you will be amazed. You will get goosebumps how simple the ionic or electrovalent bond is. Kindly watch the video till end and you will understand and you will be enjoy this lecture. Kindly follow. Now I am going to start to explain the ionic or electrovalent bond. Okay. So for first ionic or electrovalent bond, ionic, electrovalent bond. I will just mention ionic bond, right? Just ionic bond. To understand the ionic bond, you need to know atomic number of the elements till 20, right? To understand the ionic bond, you need to know atomic number of the elements 1 to 20. And you need to know one more point. Elements always try to get stable electronic configuration, right? Elements always try to get stable electronic configurations 10 or 18. Elements always try to get stable electronic configurations 10 or 18 by losing electrons or by gaining electrons, right? To understand the ionic bond, you need to know 2 points. The first one is atomic number of the elements 1 to 20, and the second point is elements always try to get stable electronic configurations, right, by losing or gaining electrons. If you know these 2 points, you can directly jump into ionic bond, right? Now I will show you. So suppose NaCl, right? NaCl is an ionic compound. NaCl is an ionic compound, right? Now I will show you how it forms. Generally, ionic bond happens between metal and non-metal. Generally, ionic bonds happen between metal and non-metal, right? Ionic bonds happen between metal and non-metal. Metal always lose electrons in an ionic bond. Non-metal always gains electrons in an ionic bond. This is also important point. Metal always lose electrons in ionic bond, and non-metal always gains electron in ionic bond. But you should ask me a question, sir, how can I know in this metal or non-metal? I don't know that. You can ask me a question. So sir, most of the compounds in chemistry, the first thing is the metal, right? The first thing is the metal. The second element is the non-metal. I think you are clear with the points. So ionic bond happens between the metal and non-metal. Metal always loses electrons, non-metal always gains electrons, right? If you take any compound, suppose the first is the metal and the second is the non-metal. I told you that metal lose electrons. So here I am mentioning sodium is the metal, so it loses electrons. So how many electrons that you need to know, right? So atomic number of the sodium is 11. Right? What I told you, elements always try to get the stable electronic configuration 10 or 18, right? 10 or 18 by losing or gaining the electrons. If you take sodium metal here, sodium metal atomic number is 1. So 11. Sodium atomic number is 11. So it always try to become 10. Sodium atomic number is 11. It always try to become 10. To become 10, it loses 1 electron. To have 10 electrons, like a sodium atomic number 11 means it has 11 electrons. To get 10 electrons, to become stable, it always loses 1 electron. So we can write Na plus electron. I think now understood, right? So sodium, it has 11 electrons. Atomic number equal to number of electrons for a neutral atom. By losing 1 electron, it becomes charged and it gets 10 electrons and it becomes stable, right? If you take, what is the another thing? Chlorine here. Chlorine is non-metal. So take chlorine. Chlorine atomic number is 17, right? But it always elements always try to get stable electronic configuration, that is 18. So it need to take one more electron and it will become Cl minus. Now we have Na plus and Cl minus, right? One is positive charge and one is negative charge. And one more important concept you need to understand here is, just this reaction is loss of electron reaction is oxidation reaction. Loss of electron reaction is oxidation reaction, and gain of electron reaction is reduction reaction. And gain of electron reaction is reduction reaction. I will give you one hint to understand, to remember this simply. Leo says jet. In this way you can simply understand LEO, loss of electron is oxidation, gain of electron is reduction. Now we have positively charged element and negatively charged element. If they are positively charged element and negatively charged element together, there is a electrostatic force, very strong electrostatic force developed between this Na plus and Cl minus, right? There is a strong electrostatic force develops between this NaCl and Na plus and Cl minus, right? In this way the ionic compound will be formed, right? I will show you one more example to make you understand better for this. Instead of NaCl, I will take magnesium chloride. Okay, instead of NaCl, I will take magnesium chloride, right? Magnesium chloride. What I told you, I will rub this also, right? I will rub this also. Take magnesium chloride here, right? First identify what is metal and what is non-metal. I always told you the first one comes is most of the cases, right? The first one came is metal and the second one came is non-metal, right? Non-metal. Metal always lose electrons and non-metal always gains electrons. So here, if magnesium atomic number, what is the magnesium atomic number? Magnesium atomic number is 12, so it need to lose 2 electrons. In previous case, sodium chloride, sodium atomic number is 11, so it need to lose 1 electron to become 10. Here, magnesium atomic number is 12, so it need to lose 2 electrons. To become 10, so we can write Mg plus 2 plus 2 electrons. So here, as I already said you, Leo says gel. So here loss of electrons is oxidation. So this is oxidation reaction. So another thing, we have chlorine, right? But you have 2 electrons, right? Chlorine generally atomic number is 17. So you need to take 1 electron. To become stable. So it will take 1 electron. But here magnesium is releasing. Magnesium is giving 2 electrons. So 2 chlorine atoms will participate, and these 2 electrons will participate. 2 chlorine atoms, by accepting 2 electrons, you will get 2 Cl minus, right? 2 chlorine atoms, by accepting 2 electrons, you will get 2 Cl minus. This is reduction reaction. I am writing again here. Leo says Z, right? Loss of electron is oxidation, gain of electron is reduction. Here Mg is losing its electron, so it is oxidation reaction. Here chlorine is gaining its electron, so it is a reduction reaction. Now we have positive charge and negative charge, so there is electrostatic force will develop between the positively charged magnesium and these negatively charged 2 chlorine ions, right? If magnesium means neutral atom, if magnesium plus 2 means it is a positively charged ion, Cl minus means negatively charged ion. So there is a electrostatic force developed between the positively charged Mg2 plus and negatively charged 2Cl minus. So thereby there is a formation of this electrostatic force is the ionic bond. In such a way, right, we can write the ionic bond for a magnesium chloride, right? I will show you now for one more compound, right? So I will take calcium oxide, right? First identify the metal and non-metal. I told you already, the first one is most of the cases is metal. the second element is non-metal. So you don't need to bother, you don't need to find difficulty which is metal and which is non-metal. Generally first element is the metal, the second element is the non-metal. If you take calcium here, right, calcium atomic number is 20, calcium atomic number is 20. So here there are two stable numbers, one is 10 and another one is 18, but calcium is 20. So what is the nearest number to 20? 18. An element always try to lose electrons or gain electrons to its nearest number. Elements always prefer its nearest number to lose or gain electrons. I repeat, an element always prefer its nearest number to lose or gain electrons. Here 20 is nearest to 18. So by losing 2 electrons, right, it will become stable. So it will become Ca plus 2 plus 2 electrons. Ca plus 2 plus 2 electrons. Now what will have? Oxygen, right? Oxygen. As we know, oxygen atomic number is 8, right? Oxygen atomic number is 8. It will. So what is its nearest number? 10. So its nearest number is 10. By accepting 2 electrons, right, it will become O2 minus. By accepting 2 electrons, it will become O2 minus. Now we have positive charge and negative charge. So there is a development of electrostatic force. That electrostatic force is nothing but ionic bond. Here electron it is losing, so this is oxidation reaction, and here the electron it is gaining, it is reduction reaction. The electron it is gaining, so it is reduction reaction. And electrostatic force developed between the calcium 2 plus and O2 minus, right? Understood? So I request you student to practice for magnesium oxide, right? Magnesium oxide and zinc oxide. I request you students to practice for magnesium oxide and zinc oxide, and I will show you one comparison here, right? I will show you one comparison to understand you better, right? MgCl2 and MgO, right? I am showing one comparison to understand you better. First step, what is here? This is the metal and this is the non-metal. This is the metal, this is the non-metal. Metal always lose electrons and become Mg plus 2 electrons. What is the non-metal here? Chlorine. How many are there? 2. How many are there? 2. 2Cl, right? Plus 2 electrons, right? 2Cl minus. Observe carefully. Here 2Cl plus 2 electrons gives rise to 2Cl minus. Here if you take magnesium, Mg plus 2 electrons. This step is same for both. This step is same for both. If you take oxygen, right? Oxygen. So by gaining 2 electrons, it become O2 minus, right? If by gaining 2 electrons, it become O2 minus. While writing the formula, 1 Mg 2Cl minus, 1 Mg 2Cl minus, so it is coming MgCl2. Here just 1 Mg, 1 O, just we are writing MgO, magnesium oxide, magnesium chloride and magnesium oxide. So write carefully while writing the equations. Here 2Cl2, 2 chlorine atoms are there, that's why we mentioned 2 chlorine atoms, it gaining 2 electrons and becoming 2Cl minus. Here only one oxygen, by taking the 2 electrons released by magnesium. I repeat, one oxygen, by taking the 2 electrons released by magnesium, it is getting O power 2 minus, right? Now the electrostatic force developed between the positive and negative charge, and it is magnesium chloride, and another one is magnesium oxide. And one more way to explain this, right? One more way to explain this ionic bond is elements with less number of valence electrons. Elements with less number of valence electrons. That means elements with 1, 2, 3 like that. Electrons in valence shell. Elements like 1, 2, 3 electrons is there in valence shell. That means outer shell, right? Outer shell will lose electrons. Generally will lose electrons. By losing electrons, they form positive charge. Right? This is losing electrons is oxidation reaction. I repeat, elements with 1, 2, 3 electrons in valence or outer shell always lose electrons. By losing, they form positive charge, and the reaction is oxidation reaction. If you take sodium as an example, if you write its electronic configuration 1s2, 2s2, 2p6, 3s1. If you write the electronic configuration for sodium, right, 1s2, 2s2, 3s1. So outer shell is what? 3. How many electron is there? 1 electron. How many electrons is there? 1 electron. So it loses electrons and it forms positive charge, and this is oxidation reaction. If you take another elements with valency 4, 5, 6, right? 4, 5, 6 gain electrons, and they got negative charge, and they undergo reduction reaction. They got negative charge and they undergo reduction reaction. If you take simple example, oxygen, right? What is the electronic configuration of oxygen? 1s2, 2s2, 2p4. See, in outer shell there are 4 electrons. So as I said, elements with 4, 5, 6 electrons in valence shell gain electrons and form negative charge, and they undergo reduction reaction. In such a way also we can explain the ionic bonding nature, right? Now I will show you the properties. I will explain the properties of ionic bond. What are the properties of ionic bond, right? Properties of ionic compounds, right? So properties, I will mention here properties of ionic compounds, right? Generally these are solids. Ionic compounds are solids, right? So I will give you a trick to understand simply. Remember NaCl. NaCl is an ionic solid. Sorry, these are solids, right? These are solids. The first point is these are solids. Remember NaCl, right? Salt. That is solid only, right? So while writing the properties, remember salt and write the properties. That it will be easy to you to remember. So ionic compounds are solids. The second thing is soluble in water. So salt is soluble in water, right? NaCl is salt. So all ionic compounds are soluble in water, right? They have high melting and boiling points. If you take sodium chloride to make into liquid, you need to go for more temperatures, or you need to go very high temperatures. If it is ice at above 0 degrees centigrade, it will melt and it will become water. But if you take NaCl solid, it is a salt. A salt is a solid. If you make it liquid or molten or fusion state, you need to go for very higher temperatures. So that we mentioned here, they have high melting and boiling points. So what is the boiling point of water? 100 degrees centigrade. What is the boiling point of water? 100 degrees centigrade. So if you want to boiling point of NaCl, you need to go even more than 1000 degrees centigrade, like that. I'm not sure, better understanding I am telling. For water if it is 100, if for boiling of NaCl, you need to go more than 1000, like that, right? That means I'm mentioning here they have high melting and boiling points. So, and they conduct electricity. One more point, they conduct electricity in molten, fusion or liquid state. That means in solid state they don't conduct electricity. Generally, in solid state they don't conduct electricity. Why? Because to conduct electricity, the movement of ions is required. It is very important to conduct the electricity. The movement of ions is required. In solid NaCl, there is no movement of ions, right? In solid NaCl, there is no movement of ions. They are held by strong electrostatic forces. That's why there is no conduction of electricity. If you take the molten state or liquid state, what is the difference between the molten and liquid state? The difference between the molten fusion, right? The difference between the molten state or aqueous state, right? Aqueous solution. The difference between the molten and aqueous solution is, if molten means directly we are converting the solid into liquid by heating it. Directly we are converting the solid into liquid by heating it. That is called molten. Aqueous solution means we are adding the NaCl to the water. That is aqueous solution. both are in liquid state only. So in solid state, NaCl, solid NaCl doesn't conduct electricity, but in molten or aqueous solution form, it conducts electricity. And how it's soluble in water, just I will show you. If you take NaCl, it contains Na plus and Cl minus ions. In that Na plus and Cl minus ion, sodium plus is positive charge, Na plus and Cl minus ion, sodium plus is positive charge. So oxygen surrounds sodium cation, right? Oxygen surrounds sodium cation, right? Cation with partial negative charge. So oxygen surrounds sodium cation with positive negative charge. If you take Cl here, Cl is a negative charge. So generally hydrogens surround Cl minus ions, right? So hydrogen will get partial positive charge. In such a way, these ionic compounds are soluble in water. And water has dielectric constant. Water is polar. These ionic compounds are so polar. That's why they are soluble. So, in same way, ionic compounds are insoluble in organic solvents, right? Ionic compounds are insoluble in organic solvents. So, what are the organic solvents? Like if you take CS2, CCl4, right? These are so benzene, C6H6 benzene, C6H5 CH3. These are toluene. So ionic compounds are insoluble in organic solvents. So I request students to remember 4 points. First, take the ionic compound. The first element is metal. The another element is non-metal. So metal lose electrons to gain positive charge. Metal lose electrons to get positive charge. Non-metal gains electron to get negative charge. So electrostatic force established between the metal and non-metal. In such a way, the ionic bond will be formed. Thank you. If you like my video, kindly share, subscribe, and thank you very much.